Hello everyone, Mr. Minix, my name, math is my game. I was thinking about today's date. Today's date is September 13th. December 12th, 2012 was the ultimate one, but I can't wait until December 12th again. You know, December 12th, in America we write the date like this, December 12th. And then in 2012 it would have been National Microphone Day. 1, 2. 1, 2. 1, 2. That was pretty lame. Anyway, here we are. Today I'm joined with my first period Algebra II class. You can tell they're really stoked to be here. I mentioned to them that I've skipped over the line stuff from Chapter 2, but here we are. We're actually going to go over this. So it's Chapter 2, Section 4, more about linear equations. Yesterday in all my classes, we talked about point-slope form, and we're going to revisit point-slope form today, in addition to the other two forms of linear equations. So the objective, if you can't read that from where your vantage point is, it says to write an equation of a line if somebody told you what its slope was and some point on the line was. So the nice thing about this is whoever's giving you these problems to try, they're doing half the work for you. Because yesterday we saw that if you wanted to write the equation given 2 points, you had to find the slope first. So the slope's already found for us. Okay. All right, let's get right to it. Point-slope form. If you were not here yesterday, if you didn't take notes on this yesterday, here it is again. Point-slope form. Point-slope form. It goes like this. It goes y minus y1 is equal to, that didn't work the way I wanted it to. That's okay. Y minus y1 is equal to m, and m is being multiplied by the quantity. M is being multiplied by the quantity x minus x1. You're probably wondering why I wrote those the way I wrote those. Somebody might know why I wrote those the way I wrote those. I didn't add the subscripts. Right, I didn't add the subscripts, but I wrote this the way I wrote it because I want to show you or remind you where this comes from. Anybody remember from yesterday where this comes from? Somebody said it. It comes from the formula for slope. Remember, the slope formula says m equals what? y2 minus y1 over x2 minus x1. So all we did was we kind of just jumbled around the slope formula. That's where point-slope form comes from. Okay. Now, in one of my classes, we got to discuss the advantage of this. This would make a nice essay question if I were ever to write an essay test, which I might. Anybody that's been in my math classes knows that I like essay questions. So here's an essay question. Why do we use point-slope form? And hopefully we'll be able to definitively answer that when we look at our first example. Why do we use point-slope form? Okay. So a precursor, a preliminary idea to point-slope form is another one that people think is standard form, and it's not standard form. And once you see it, you'll know what it is, and once you say it, you're like, oh yeah, I remember that from lines. There's one form of linear equations that almost everybody on the planet knows. I'll bet y equals mx plus b. I'll bet Mr. Massey knows it. Okay, what's the name of that form? What's the name of that form? Slope-intercept form, right? That's slope-intercept form. Okay, so if we had let's pretend for a minute when we look at example 1, let's pretend that we didn't know point-slope form and we knew slope-intercept form. What I'm going to do is I'm going to work out example 1 using slope-intercept form, and then again using point-slope form, and I'll let you determine if you can see why we use point-slope form. Okay, here we go. Example 1. I'm going to put this on a brand new page. And yes, I just did say bland new page as opposed to a brand new page. Send it to a new page in the smartboard. Here we go. So they, the authors of the book, the ones who are giving us this problem, they gave us some point that the line goes through. Now, I like to label things. I really like to label things. So I'm going to label that point. This part of that point, I'm going to label as x sub 1. Does that make sense? It's the first and only x given. And then, so this 2 is the y sub 1. And the slope, of course, that's our m, right? So if we didn't know point slope form, yet, point slope form yet, we're going to pretend like we don't know it. We're going to pretend like we don't know it. And we're just going to work this problem out using slope-intercept form. Slope-intercept form. So here we go. We could probably make some substitutions because we know that y equals mx plus b. So we know that y is what? Y is 2. We know that m is what? 3 over 5. And we know that x is what? Negative 5. And then plus b, right? Now, I left my negative 5 kind of weird. I left some space. What am I going to put underneath that? Yeah, 1. That's over 1. Fraction multiplying. Whenever you multiply fractions, if you've forgotten how to do that, don't forget, you multiply across the top. And you also multiply across the bottom. But in this particular instance, we can actually, can't we cross-cancel those 5s? Okay. So the deal is, we get 2 equals, those 5 cancels, but there's a negative 3 times, well, anyway, that's negative 3 plus b. Don't get it twisted, that's not a 6. My b's look like 6s. So what's our b value end up equaling? B equals what? Is b going to be positive 5, right? Okay. So the directions asked us to write the equation of the line, right? Have we written the equation of the line? Not yet. That's a big point. We haven't written the equation of a line yet. All we've done is found the y-intercept. So there's still one more step left to do. So our answer is this. Y equals mx plus b. Well, what's my m? 3/5, that's given. So y equals 3/5 x, and then plus b. So then what? Plus 5. Okay, so that's the way the cookie crumbles. That's the way I like it. That is what you probably did in algebra before you learned about point slope form. Right? So, we're trying to answer this essay question. This question, why do we use point slope form? So, to answer that, we're going to go back, we're going to rework the same problem. Oh, we just did it, we know what the answer is. Of course we did. But we're going to rework the same problem, but this time using point slope form. Point slope form says y minus y1 is equal to m times x minus x1. So this first y is going to remain y, but I'm going to make a substitution. So I'm going to replace the y1 with what y1 is, and y1 is the 2, right? So I got y minus y1, which is 2, equals m. We know m is 3/5. Times the quantity x. I got to be careful here. What's minus 5 going to be? It's going to be plus 5, right? All right. So PEMDAS. Multiply, we'll distribute that. That's going to be 3/5 x. When I multiply that 3/5 by 5, I think we saw what happened earlier, right? What's that going to be? 3, so that's going to be a plus 3. And that's what y minus 2 equals. One more thing to do. What's that? Add the 2 to both sides. So we add 2 and we get y equals 3/5 x plus 5. Now you're thinking, big deal. We did the same thing. We got the same answer. Well, it is a big deal. It is a big deal. If you compare those two things side by side, when we did that with the y equals mx plus b method, we found b, and we had to go and write the equation, right? So what's the advantage of point-slope form? It gives you the equation. It finds b and writes the equation all at the same time. It's kind of like going to Cleveland in your 79 Buick Skylark. You could just drive there. But if you're hungry and you wanted to go through the drive-thru and you had about $20 to buy 2 beef and cheddars and a curly fry and a Jamocha shake and maybe one of those cherry turnovers, and you could drive with your knee, maybe you could enjoy those 2 beef and cheddars and the curly fries and the Jamocha shake and the cherry turnover on your way to Cleveland. Maybe you could get both done at the same time. And that's what point-slope form is. It's like multitasking. So that's why we use it. We use point-slope form. If you missed it, I'm not going to write it down. I'll let you write it down. We use point-slope form because it writes the equation as we go. When we use slope-intercept form, it lets us find the b, but we still have to write the equation then. Okay. So we're going to do one more of these. We're going to do this Gauting. Try this one. And I'm going to give us a choice here. We're just going to see what we want to use. What do we want to use, point-slope or slope-intercept? Point-slope? Okay. Does anybody want to see a better version of point-slope form? They don't teach this in the textbook. They don't teach us in the textbook. I like to use what's called point-slope plus. Point-slope plus. So instead of y minus y1 equals m times x minus x1, wouldn't it be nice if we had something where the y was all by itself? Because that's what we're after, right? Y equals something, 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 something. So check it out. Check it out. All I'm going to do to this is I'm going to take this y1 and I'm going to slide it over here. But when I do, it was negative on the left side of the equation, right? When I put it on the right side of the equation, what's it going to do? It's going to become positive, so I'm going to have a plus y1 here. Okay. I call this point-slope plus. I love it. I love it. I love it. So here we go. Y equals m, which is negative 3, times x minus x1. What's my x1? I got to be careful. 7, good. Close that, and then plus y1. So then what am I going to have? A minus 1 on the side. Good. So let's distribute. We get y equals negative 3x, and then what? Minus 3 times minus 7. That's plus 21, and then minus 1. So my final answer is y equals negative 3x, and then plus 20, and then that's it. And then that's it. And then, oh, I would like some crispy noodles and a root beer with no ice. No ice. And then, question. So the question is, what would the difference be if there were a y2? I am so glad you asked that. You have ESP. You're thinking ahead. The question is, if we had 2 points that the function went through, that the line went through, what's the difference? We're going to look at that right now. This next example, remember I told you they kind of did half the work for us? Well, not in example 2. Oh man, why do they got to be that way? In this one, they've only got 2 points. They don't tell us what the slope is. But we're going to answer your question in just a second. So we got to find the slope first. So here we go. If you missed it on yesterday, the slope formula is y2 minus y1 over x2 minus x1. Those subscripts, a lot of people get subscripts twisted. They think it means multiply by that. No, it doesn't. Some people don't understand subscripts. It just means it's the first one. It's the second one. It's the third one. So when we talk about x2 is this 5. When we talk about y1 is this 2, because it's the first y value. Okay, so x1, y1, x2, y2. So when we make substitutions, we're going to have 8 take away 2, divided by 5 take away 3. So that's going to be 6 over 2, which is 3 in simplest or lowest terms, right? So we have a line whose slope is 3. What are we going to use to write the equation of the line? Are we going to use point slope form, slope intercept, or point slope plus? Point slope plus. So the question was x1, y1 versus x2, y2. The deal is, if you found the slope right, and if you make the calculations right, it doesn't matter which of those 2 points you use, you'll get the same equation both times. You'll get the same equation both times. So let's look at this. Let's try using the x1, the actual x1, y1. So point slope plus was y minus y1 is m times x minus x1. Oh, no, it's not. We're doing point slope plus, aren't we? So that's a plus y1 on the side. There we go. Okay. So if we use the 3 and the 2, we're going to have y equals 3 times x minus 3 plus 2. So what do we get? We get 9x. No, we get 3x. I'm gonna skip a step here. 3 times negative 3 is negative 9, and what's negative 9 plus 2? That's going to negative 7, right? So if we do the math right, if we use the other point, not that we have to, y equals 3 times x minus 5 plus 8, that's going to be 3x minus 15 plus 8. Oh, dude, it's the same answer. So point slope plus could have said y minus y2 equals m times x minus x2. But they're kind of assuming that you only have 1 point, and that's why the subscript is 1. Does that answer the question there? Okay. So we get the same answer either way we shake that one down. Now, I would really love to show you more than one way to the Eastwood Mall, because let's face it, there is more than one way to the Eastwood Mall, right? So let's go and use our resources. Now, I'm not encouraging this, but I am telling you that if you wanted an answer, you could go to this website. You could put in some points, 3, 2, and 5, 8. I'm not encouraging this. I'm saying if you can't figure out what an equation is, you want to check to see if you're right, you could put in the coordinates 3, 2, and notice the comma, and 5, 8. You could put in those 2 points and check it out. It is intuitive. It knows what you should be doing with this. What do you want to do? Well, you want to find the equation using point slope form. And there's your answer. Y equals 3x take away 7. Just like that. So you're doing your homework exercises. And you do all 18 of them with that. And you go to take the quiz on next week. I'm not saying what day because I don't know what day. But you got to take the quiz on next week. Is using that solely using that going to prepare you to take that quiz in room 203? Probably not. There's got to be another way to do this, and there is. I don't know how familiar most of you are with the calculators, but if we labeled a list here X and another list here Y, and we're going to take time out of class to do this at some point. Probably not this week, but we will at some point. If we labeled these X and Y, and what was our 1 point? Was it 3, 2, and 5, 8? So we had X's of 3. I'll just use my computer to go smoother here. So we had a 3 here, and a 5 here, and a 2, and an 8. What I could actually do here is I could do something we're going to do in the future. I could calculate a statistical calculation, and the calculator could do that for me. It tells me what my slope is, it tells me what my y-intercept is. It doesn't write the equation, but it gives me the m and the b. And we'll talk more about how to do that, like I said, probably next week. Okay, so if you missed that, I know I went really fast through that. There is more than one way to the Eastwood Mall, though. So let's think about this. We saw slope-intercept form. We saw point slope form. We saw point slope plus. We saw Mathway. We saw the calculator. You think there's another way still to get the equation of a line given 2 points? Yeah. Heck yeah, graph it. Somebody said graph it. Yeah. Yeah, that's a fantastic idea. The only drawback to the graph is it's not always going to work out where everything's integers, but a graph is a great idea. 3, 2. There's the point. 3, 2. The other point was 5, 8. 5, 8. 1, 2, 3, 4, 5, 6. 1, 2. Well, I guess that's 5, 8 up there. Okay. There's the point 5, 8. So if you have good graph paper, if you use graphing utilities properly, if you use a straight edge, and connect the dots in the right way, this should work out right. Check it out. Is our y-intercept -7? All right. And how do we find the slope? Well, slope is rise over run. Slope is rise over run. So our slope is, let's see, 1, 2, 3, 4, 5, 6, up 6, and then over 2. So graphing is an awesome idea. When you take the quizzes over this, I will have graph paper available for you to use. Okay. All right. Well. Oh, no. Why do they got to do this? Before we get to standard form, I do want to look at one last of these Godding examples. I do want to look at a Godding 2A. Godding 2A. When I see this one, I love it. I love it, I love it, I love it, I love it. Who could tell me why I love this particular problem? The zeros, yeah, zeros are nice to work with, but more specifically, one of those pairs of points I really love. Which pair of points do I love, the -50 or the 07? Why do I love the 07? Undefined? No, not undefined. What do we got? It's on an axis. Somebody said something about it being positive. I like positive numbers, but 7. 7's my what? Let's think about this. We wanted to write an equation of the form y equals mx plus b, right? What's 7? The b. Now, some people get it twisted. Some people will see one like the last example, and some people will assume, hey, the y-intercept's 2. The y-intercept's not the y value. The y-intercept is only the y value whenever its corresponding x value is 0. Okay? This y is only the y-intercept if its corresponding x value equals 0. Be real clear on that. Okay? So on this one, we could answer 3/4 of the question without even doing any work, right? Or I don't know how much of it. We could write that much, and all we'd have to do now is find the slope. Okay? Got him? Got the idea? For completion's sake, let's go ahead and calculate the slope. It's 7 minus 0 over 0 minus -5, so that's 7 over +5. So the slope is 7/5. Okay? Questions? Comments? Concerns? Short debates, long debates? Well, that reminds me of something. You know what it reminds me of? Decimals. I don't know why people like decimals. They're going to take the quiz, they're going to take the test, and they're going to take 7 divided by 4. They're going to take 7 divided by 4, and they're going to make a decimal out of it. Or 7 divided by 5, I think it was, right? Sorry, 7 divided by 5. I said 7 divided by 5, and they're going to make a decimal out of it, and they're going to write 1.4, okay? So they're going to put the slope in as 1.4. If you had to graph that, do you understand what it means to go up 1.4 and over 1? Could you do that on a piece of graph paper very well? No. Fractions are good. Fractions are fine. Let's use fractions. Okay. If you're a decimal person, get out of that habit, please. If you're a decimal person, get out of that habit. Very bad habit to be in. Okay. All right. So, I guess the last thing we need to talk about on today is standard form. You'll hear me joke. It's no joke. This is the form you don't want the abbreviation to. Okay? I don't know from experience, but you don't want the abbreviation to standard form. Okay? 8x plus by equals c. There's some very interesting things here. I don't like the way the book describes this. They say that a, b, and c have to be real numbers. Okay? I'm going to take it a step further. I'm going to say that a, b, and c ought to be. They ought to be. I'm going to take it a step further than saying they're real. Because a lot of times you are asked, you are asked to put something in standard form with integer coefficients. So I'm going to say that a, b, and c ought to be integers. They ought to be integers. Those are whole numbers and their opposites, in case you didn't know. So a, b, and c ought to be integers. And I'm going to take it one step further, and a is positive. Now, I didn't write a as positive. I wrote a, and then the greater than sign is 0. In advanced math, that's how we say something's positive. We say it's larger than 0. The reason I do this is because if you didn't do that, there would be an infinite number of answers you could have when you're writing the equation in standard form. There's one more thing I have to say, but most of you probably won't understand the term. In addition to a, b, and c being integers, in addition to a being positive, a, b, and c, a, b, and c ought to be, big word here, has nothing to do with West Virginia or Wyndham. A, B, and C ought to be relatively prime. A, B, and C ought to be relatively prime. So you probably have a zillion questions right now, and I'm going to answer them with an example or two or three. Okay? So something to notice about the standard form. The x is first. The x is on the left, followed by the y, and then the equal sign. And on the right side of the equal sign is just a number. Okay? So if you don't get that, if you don't understand exactly what standard form means, check it out. Make a note of it. X is first, followed by the y, followed by an equal sign, followed by just a number on the right-hand side. So if we had something like this, 3/5 x plus 4y equals 6. Suppose we had something like that. Does that meet my criteria to be in standard form? I heard somebody say yes. Does it? Well, I say A, B, and C ought to be. They ought to be relatively prime, but A, B, and C also ought to be integers. Is A an integer? No. So how do we get rid of the fraction? Remember when you learned about solving equations? Whatever you do to one side of the equation, you do to the other side? It's kind of the same thing as doing that to the whole equation. So I could multiply the whole equation by something to get rid of the... By 5/3? If I multiply by 5/3, it's going to make a fraction coefficient for my y term. Just multiply by 5? Let me multiply by 10. I'm going to multiply by 10. So that's going to make that 6x plus 40y equals 60. Are 6, 40, and 60 relatively prime? Are 6, 40, and 60 relatively prime? They're not. 6 and 40 are both even, and 60 is also even. So they're all divisible at least by 2, right? Scratching my head. So I could reduce this down because I could divide the whole thing by 2, right? So that's going to give me 3x plus 20y, and that equals 30, right? 3 and 30 aren't relatively prime, but all three of these, 3, 20, and 30, are relatively prime. So whoever said we should have multiplied by 5 in the first place, we should have multiplied by 5 and we would have got there a little quicker. Okay. Do we kind of understand what relatively prime means? Relatively prime means there's no common factors amongst the three. There's no common factors amongst the three. 3 and 30 have common factors. But if we look at 3 and 20 and 30, they all three don't have anything in common. Okay. So let's try to answer question 3. Notice I said try. I feel like Yoda sometimes. Which reminds me of Star Wars. Anybody a Star Wars fan? Did I already tell you about Luke Skywalker and Darth Vader? I think I already told you that one, so I'm not going to tell you about them. So here we've got y equals 3/4 x minus 5. And our goal, remember our goal, what we want to have happen is some kind of x. We don't know the coefficient. Some kind of y. We don't know the coefficient. An equal sign, and some number. We don't know if it's positive or negative. What we do know is that whatever goes right here, whatever goes right here, whatever goes right here, all of those should be what? They should be, I'm hearing somebody say positive. We can't guarantee that they're all positive. They all need to be integers, and there is one that we want to have positive. A. We want to have this one to be positive. We want that one to be positive and all of them to be integers. Okie dokie. I solve equations way different than a lot of you. What I'm thinking in my head is that this term here, this is a term, this term needs to go over to the left side of the equation. Do you see that? And when it does, its sign changes. Its sign changes from positive to negative. So when that term goes to the left side of the equation, I'm going to have on the left side of the equation negative 3/4 x. Hey, I've got my x term first. That's good. And then what? Plus y, right? Plus y. Hey, I got my y next. I'm in pretty good shape. Should I move the negative 5, or should I leave it on the right side of the equal sign? Leave it, it's good. Equals negative 5. So let's see. Are all these coefficients integers? No. Is my leading coefficient positive? No. Now I could, if I was smart, I don't like the S word. If I was intuitive, if I thought a little bit, I could multiply that equation by one number and make a positive and get rid of all the fractions all at the same time. What would I need to multiply the equation by? 4 would make everything an integer, but it wouldn't make a positive. Negative 4. We're going to multiply by negative 4. Okay. Multiplying by negative 4 will ensure that a is positive and that we have all integer coefficients. Be careful here. Make sure that that negative just gets distributed. Make sure the 4 gets distributed to all the terms. Okay. So what's my first term going to be? I'm going to have 12/4, which reduces down to 3. So my first term is what? 3x. Now I'm taking y and multiplying y by negative 4. What's that going to give me? Minus 4y. And then negative 4 times negative 5 is going to give me 20. 3, 4, and 20 are all relatively prime. A is positive. All coefficients are integers. Whoop. There it is. How do we feel? Got him? What do we think about graphing standard form equations? Oh no, we're going to have to do that? Yeah. There it is. We're going to be graphing this, and this is the last thing for today, I promise. I guarantee it. Here we go. What did we say earlier about a y-intercept? A y-intercept is the value of y when? when it's x is 0, right? If x were 0, would that 3x term kind of disappear like that? You see what I got going on? Let me rewrite the equation a little bit bigger. The equation is 3x plus 5y is 15. Okay? If I'm finding my y-intercept is the value of y whenever x is 0. When x is 0, this is going to be 3 times 0, and that term goes away, doesn't it? So let's solve for y. What's y? Y would be what? 3. So my y-intercept is the point 0, 3. Right? Let's do the same thing for the x-intercept. An x-intercept is the value of x when? When y equals 0. When y equals 0. If y equals 0, I'm going to have 5 times 0, which is going to make this term go away, isn't it? So what's my y-intercept? My x-intercept, sorry. My x-intercept is 5. How many points do I need to make? Oh, I just about had one of those moments. How many points do I need to make a line? I need 2 points. I got 2 points. I got 0, 3. Let me get my axes clearly defined here. Yeah, you know what I call this? I call this the cover-up technique. Because did you see how I covered up the y to get my x-intercept and covered up the, okay? Yeah, it's plugging in zeros for the opposite one. Yep, cool. So our y-intercept is 0, 3. Our x-intercept is 5. 1, 2, 3, 4, 5. The line goes like this. What about my slope? Is my slope positive or negative? Slope's negative. Could I write that equation into y-intercept or slope-intercept form? Let's try that, and then that's it. Let's try to write that equation in slope-intercept form. So 3y. Whoop, don't want a line. I always forget about that. 3y plus, or was it 3x? 3x plus 5y equals 15. Let's put this in slope-intercept form, and this is it. We'll end here today. So what should I do first? Slope-intercept form is y equals mx plus b. So I want the y all by itself, so what should I do first? Yeah, I got to take this 3x term and put it on the other side. So 5y equals negative 3x plus 15. And then what do? Divide by 5. When I divide by 5, I'm going to write it a little bit different than you're probably used to seeing. I'm going to write divide that by 5, divide this by 5, and divide this by 5. Okay, rather than I'll put everything over 5. I think it makes it a little more clear what happens. Our final answer here then in slope-intercept form is negative 3/5. I left something off of there for a minute. What did I leave out of there? X. Who in here likes to make slanted fractions? Anybody? Slanty fractions. When you write your fractions, you write your fraction like that. Anybody like to make slanty fractions? If you're writing slope, don't do it. Don't do it. Reason I say that, let me zoom in on this for a minute. What did I leave out of my equation? I forgot to put in there an x. So let me zoom in on this. I said let me zoom in on this. I said let me zoom in on this. There we go. See what's going on there? Can you tell if the x is next to the 5 or next to the 3? It looks like it's next to the 5, right? Watch what happens if I graph that. Watch what happens if I graph that. If I graph y equals a fraction with 3 over 5x plus 5. Now, what have we been studying here in Chapter 2? What kind of objects? They're comprised of 2 points. What are we studying? lines. And most people would agree that lines are straight. And lines go on forever and ever with no breaks or holes in them, right? Where do you see this? Does that look like a line to you? Does that look like a line to you? What I'm saying is it's a big deal where you put your X, okay? It's very, very important that your X isn't in the denominator. So if you have a 3/5 here, that's going to go away because that's a magic marker. If you have a 3/5 here, you got to be real clear where your X is. X is on the side. X is with the 3. X is not down here with the 5. If you inadvertently write your X down here on an upcoming test or quiz, I will have to deduct a point because you can clearly see that that's not a line, right? So you might say, but Mr. Minnick, how do I solve that? How do I fix that? Well, then you would write y equals -3/5 x like that. That make sense? Then plus 5. That's all I got. It's been real. It's been fun. I hope everybody has an awesome, awesome day. I'll see you next time. Good.